to meet all of you. I am Sarah. So I'm a developer advocate with Filecoin. If you've ever used a Filecoin Virtual Machine, we've been around for a while. And now we're launching a new incoming scalability framework called InterplanetaryConsensus. So going to give a little small talk today around how we're going to scale Filecoin with IPC. Cool. So nice to meet all of you. Thanks for coming on the first day of Biddle Week. Apparently, I am the first talk for Biddle Week, which is kind of cool. It's a little bit of a cozy stage right now, so I'll be around later if you want to ask any questions. Yeah, so let's get started. Cool. So going to give some context. So as I just mentioned, there's Filecoin and there is InterplanetaryConsensus. These two are separate products, but they are built with the same team. The team that brought Filecoin is also going to build IPC. So some context here that I'm going to share on how we came to make this decision to build IPC. I always find that context is super useful. We had the Filecoin master plan. You might have seen this from our CEO, Juan Benet. The idea here was really to have this vision for humanity, where we would first build the world's largest decentralized storage network, followed by onboarding a ton of data, important, valuable data, which we are in the process of doing. And then step 3 is to bring computation to that data to enable web-scale applications. So that's kind of where we launched the FVM, which is the Filecoin Virtual Machine. Again, this was fully EVM compatible. You must have seen us at a ton of ETH Global hacks that we did last year. We had, I think, a total of about 700 hackathon teams that have built with FVM to date. And we had last year, we had roughly about 70 teams that built with us for a good 6 months or so, and 20 of them went on to accelerators, right? So kind of showing you the traction that we had, and we were building with them for a good 6 months to a year. This led us to a lot of learnings and realizations, and that's also what led us to decide to build and design this new scalability framework. So just taking a step back, for those of you who are new to the Filecoin Virtual Machine, what it is it launches on-chain programmability for the Filecoin network. So if you have heard of Filecoin or you've used IPFS, you would be pretty familiar with the ecosystem as a whole. For a long time, it was an L1 on its own. You couldn't really do much programmability on it. And to do a storage deal to get your data stored, you would have to go through a pretty manual process of arranging with a storage provider to store your data, et cetera, et cetera. So just not going to cut it, right? So like we were thinking about how we could make that a lot faster, how we could enable on-chain incentives, on-chain contracts that will allow people to store their data based on the most affordable rate, based on what their criteria was, maybe based on region and so on. So a lot of that functionality was enabled with the Filecoin Virtual Machine coming about. This was built with Wasm Time under the hood. It's a whole virtual machine that sits on every node of Filecoin today, and you can still continue to use it. So it was great to get people starting to build these storage solutions, right? So we saw things that came out of it like data DAOs, for example, where you could have a community that contributes content and gets rewarded for contributing that content, or maybe pools together their funds to sponsor the retrieval of that data, depending on how they want to use it. So we had a lot of use cases just like these, and that's what led to a lot of traction on the FVM. So as I was saying, that led to some realizations and some learnings, right? So because these were being built on the Filecoin L1, Filecoin today runs a 30-second block time, which means that if you build an app, you're going to have to wait about 90 seconds for that transaction to go through. And I think all of us know here, you wouldn't use an app that takes you 90 seconds or so, right? Unless it's a long-term, like maybe DSI, archival storage, maybe that will cut it. But for majority of applications, no. So we started thinking about how we would build a scalability framework for this, how we could bring, because there was a lot of demand to build applications, accessing data really quickly, right? Data is everywhere. So we were like, how can we make the transaction speed faster without changing the protocol per se? So that's how we came out with the InterplanetaryConsensus. So just adding in, this is just me inserting step 3A that I see right now, which is what my new team, InterplanetaryConsensus, is building. We've decided that there's like a need for us to enable high-performing applications that surpass Web 2 standards, and we don't just want to do it on Filecoin, right? The first chain that we're targeting is Filecoin, and I'll talk about how all of that works later on. But TLDR, we're going to go really strong on Filecoin right now, allow that to scale up, and then introduce the scalability framework to more of a multi-chain ecosystem, because the future is multi-chain. And so we'll be targeting chains like Ethereum and Bitcoin and so on moving forward. So really exciting stuff coming in there. So I hope this gives you a little bit of the context as to how IPC came about, right? Because we know that there are a lot of scalability solutions out there today. This is where we're coming from, and I'll talk about what we intend to offer to the scalability space. Yeah. So InterplanetaryConsensus is a scalability framework that promises planetary level performance of Web3. What does that actually mean? That actually means being able, and I'll show you later on how you can really increase that performance with the design that we have for IPC right now. It is still being built, and I think we're more at the alpha phase, but we have put out certain like builds that you can start testing around, playing around with, and we are participating in this hackathon too, so I'll share some resources that you can go use if you're going to be hacking at this weekend's hackathon. IPC also delivers highly flexible scalability framework. So there are a lot of things that you can configure. You could configure your native token, your gas fee schedules, membership. You could spin up subnets, and I'll talk about that in a bit. I'm getting ahead of myself, but really highly flexible is the promise here. And then lastly, to power a new generation of applications, which I think to us, the lines, it's more effective, and this is for the Web3 ecosystem as a whole, to think about developers not being Web 2 or Web 3 per se. I think we're all trying to get to the same solutions. How can we really bring that breakthrough using decentralized ethos to enable these solutions that surpass what Web 2 currently offers, right? So that we can, as a whole tech ecosystem, really deliver impactful solutions on the whole. So that's really the vision that we have for IPC. So a few key things that I'll dive a little deeper into, and then I'll take you through the architecture after this. Infinitely scalable. So we're thinking the aim for IPC is to provide Web 2 level speed using recursive blockchains. And when I say recursive, what I mean is that we're thinking of L2++. So you have your L1s, you have your scalability frameworks on top, which are your L2s. IPC right now promises the ability to spin up subnets that go L3, L4, so on, so on. So how these will all connect is that they will be connected through hierarchical consensus, which we refer to as recursive scaling. Your consensus on, let's say, your L4 will be connected to the consensus or the security based on your L3, and then upwards to your L2 and your L1, and so on. So you are borrowing a lot of components from the previous level above. And the good thing is that in terms of finality, in terms of security, if you're choosing a root net at the L1 that is one that you really trust, that level of security should then trickle down all the way to your L4s. And you can also spin it up, shut it down, and it should be really cheap and efficient. So that will allow you to increase the performance of your dApp. Let's say you want to shard transactions into a separate network, you want to shard computation into a separate network. That's the vision that we have, and it should be permissionless. So anyone can come in and build something, spin it up, shut it down based on what you need for that day, that month, that year. And that's the vision that we have for IPC. And of course, cross-net and cross-chain communication is also something that we're developing. We recently just enabled a single hop GMP from an L1 into an L2, so that can communicate pretty seamlessly right now. Eventually, what we aim for is that you can seamlessly communicate not just from a single root net and the entire hierarchy down through that, which we've already well on our way to accomplishing. It's also to be able to seamlessly call cross-chain communications, which you could previously not do as quickly or as efficiently in Filecoin because of the finality that it has. But with the IPC subnets that you have, with shorter block times on all of these different subnets, it will be much faster for you to execute those messages cross-chain, and then get it within that single subnet that you have. And that should be as seamless as possible without you having to copy and paste a separate application onto a separate chain altogether. So yeah, deeply customizable. So what we mean here is that we're using Tendermint under the hood, and I'll run through the architecture in a bit. we're using Tendermint, but we are also only using the Tendermint portion of it. We're not using the Cosmos SDK. Cosmos SDK is written in Go, so by only focusing on Tendermint itself, we've developed application logic that is using Wasm time, using Rust, so it will allow you to have a lot more flexibility with the frameworks that you want to use to apply your application logic. You can build various instances of it. So for example, now we're building a certain application logic, but we can always switch it up really quickly. So the goal is to be as modular as possible under the hood, which then also allows users that build on top of it to use whichever frameworks that they're comfortable using. What I was talking about for Tendermint, which is the adapted version that we've built, is called Fendermint. That is the IPC main instance itself. There is an application layer on top of that, the execution layer, that runs on Filecoin Virtual Machine, which the good news is also built with Wasm time under the hood, as I mentioned earlier on, which then also allows developers to build with whatever frameworks that they prefer. So really, it's customization at all different levels, not just at the main instance of IPC itself, but also in the application execution layer. Yeah, so deeply customizable, and you can customize the network as to what you need. And I'll run through some examples of this. And then lastly, modular and interoperable. As I mentioned earlier on, multi-chain is really the goal for us. We want to make sure it's fully EVM compatible and also be targeting other chains in the future. So I talked a lot about IPC and its subnets. I'm going to run through a little bit of how we envision this working. What does implementation look like with IPC? So as you can see from this graph over here, I talked a little bit about hierarchical consensus earlier on. The goal is to have your L1 mainnet. There are various things that you can do here, right? You can either scale horizontally or vertically. You could have like a gaming, let's say you're a single ecosystem or a single application, and you want to have a really high-performing network for gaming, right? But you also want to be able to tap and store data and retrieve data or compute over data in a database subnet. So you could set up these two separate subnets and have them branch out to further subnets based on whatever needs that you need to run. So you could run like a separate games, and then from those games you can run them within regions. If you're running into like GDPR privacy restrictions and you want to be able to enable that, you could also spin that up. So it really enables you to build based on whatever needs that you have in your application. But honestly, the possibilities really go pretty far, right? And then, of course, from that separate subnet, different subnet networks that you have, these can communicate across to each other, as what I mentioned earlier on, seamless communication. So that really allows your entire ecosystem to work really closely together. And also, as I mentioned, you could always shut those down. So if, let's say, you think one network is being really expensive, or you only want to run it for, let's say, one customer for a short period of time, if they go off the network, you can always shut that down and save the cost there. Yeah. So that's the vision for IPC. Some use cases, I talked about gaming and database example earlier on. You can also do it by regions. We had some teams hack with us, I think in Istanbul, and they were trying to build like a region-based voting system with IPC, and that worked out pretty well for them in terms of storing their data. You could also have a whole general purpose network for scaling. That's really for you to decide. Yeah, you could really decide what L1 you want to be building on. So there are a few different use cases that you could build here. But yes, generally, that's the idea for IPC. So as I mentioned all of this, I'm sure some questions that you've had in mind. We have had builders reaching out to ask us, how does IPC compare in the scalability space today? We know that there are a lot of awesome solutions right now in the scalability space. A few things that we think we offer differently, and we would love to. We are working really closely with a lot of hackathons to get builders to give us direct feedback. So same as this hackathon, we are around. I'll share some links on how you can talk to the team. I'll be around too. We want to get some feedback. But this is what we're targeting. So we're targeting it to be a scalability framework, which will allow you to build, it could resemble a roll-up, a sidechain, that's up to you. But you could also, branch that out a lot more, have one subnet be a rollup, one subnet be a sidechain. It's up to you. So we want to provide a scalability framework. As I mentioned earlier on, we're also building with what we call Fendermint, which is an adaptation of Tendermint. Tendermint along with the core Tendermint, along with customized application logic that can be developed for different use cases. So we have some customers that are building with us early on today, like Fluence, which will be, you should look out for their DPIN Day event. They'll be launching something really cool, a decentralized compute network. They themselves have built out their specific instance of IPC together with us. And that's because we had Tendermint core running under the hood that allowed them to build the application logic that they needed. We're also using ABCI++, so this is borrowed from the ecosystem, but again, really useful because it allows you to vote on transactions before they get executed. So you are also able, as you run all your different subnets, not having those blindly execute transactions. You might have a malicious validator or user in there. So it allows you to vote on these different transactions that are coming in before they actually get executed. So that's super useful. And because we're using Tendermint, that allows us to build with whatever custom application logic we want, that allowed us to implement IPLD storage, which is super useful for checkpointing chain state. So the way that rolls up your L4s or L3s roll up to your L1 is based on checkpointing their chain state up to you to determine for your subnet, let's say every 30 seconds or so. This gets stored within the IPLD framework, which is represented as a graph, which is really efficient for storage. So that's really under the hood, but it's a really elegant piece of infrastructure that we have running under there. Also, all messages will be stored in a CID format. So if you're familiar with IPFS or Filecoin, you'll be familiar with the content ID format. All messages will be stored that way. So it's much more efficiently stored. You're not actually storing the entire message. You're just storing that hash. Right? So that's the IPLD storage architecture that we have under the hood. And lastly, we have FVM as an execution layer, which is, again, set up for multi-chain. So FVM as a whole, set up for multi-chain. IPC on its own as well, set up for multi-chain. So we're really well positioned to go into the multi-chain space. So that's a really, I know this is a short talk. This is like a summary of what's upcoming for IPC and what we're building right now. Again, we're in very early phases, but if we have a hackathon challenge statement, so if you want to test it out yourself, play around with it, see how it compares. Bear in mind, experimental tech. This is still a little bit clunky for my liking, but you can definitely check it out. It's usable. You can do it within 15 minutes, set up your own first subnet, configure it around, see how you want to play with it. We have, I think, in the link that I'll share right after this, some deep dives on how you can do more advanced configurations. So you could even, so right now this is pretty vanilla, and you can maybe configure the number of validators that you have, the block time that you want in that subnet, pretty vanilla. We have a workshop when recording in the links I'm going to share right after this that goes deeper into advanced customization, and that's really exciting because you can actually customize the system calls within your subnet, and you can also customize your built-in actors or built-in smart contracts within the custom subnet that you have, which means that you can unlock a lot of capabilities there. So really, the world's your oyster, right? If you want to implement some GPU workloads, configure some syscalls to enable that, and run some light ML task, you could also be doing that with IPC as of today already. So definitely check that out. But yeah, and if you want to follow us, we'll be in Denver. We're giving a ton of talks across the whole week. If you scan this link, you'll find our link tree. Look for the Meet Us in ETHDenver link. You can see where we'll be at. We'll be giving some workshops, some talks, some keynotes. Juan will be here too, our engineering leads and so on. So yeah, we're really excited to meet more folks here at Biddle Week. Cool, thank you.